Hi friends, it's all about chapter number 7, Fundamental Principles of Organic Chemistry. And here we go with hybridization. So in hybridization, the learning objectives are what is shell, what are subshells, what are orbitals. So before starting hybridization, it's very necessary to understand all these mini concepts. Then the shapes of orbitals. Here we will do hybridization with carbon. Then why we need hybridization? There are three types of hybridization takes place in carbon: Sp3, Sp2 and Sp hybridization. While at the end of the lecture, I have a very tricky slide for you. By knowing that, you will be able to do hybridization and you will be able to understand hybridization in any compound. So let's start. Now before starting hybridization, it's necessary to know about these little concepts. That what is shell, what are subshells. So let's start from the shell. The orbitals present around the nucleus are called shells. Now we know that atom is made up of electron, proton and neutron. While the protons and neutrons are present in the nucleus and electrons revolve around the nucleus. So where they are revolving? They are revolving in shells. There are four types of shells: K, L, M and N. And all the electrons are present in these shells. These electrons are responsible for chemical bonding. These electrons are responsible by which atom is able to make bond with other atoms. Subshells. Now the components of the shell are known as subshells. Like if I say that a house is a shell, then the rooms in the house will be the subshells. So there are four subshells: S, P, D and F. Now these subshells, S stand for sharp, P for principal, D for diffuse and F for fundamental. How many number of electrons will gonna revolve or stay in these subshells? Like in S subshell, it can accommodate 2 electrons. In P subshell, it accommodates 6 electrons. In D subshell, it accommodates 10 electrons. And in F subshell, we have 14 electrons. You have studied about this in first year or in previous classes. So it's all about subshells, which are the components of shells. Now here are the orbitals. S subshell has one orbital. S is spherical in shape, while P subshell has 3 orbitals: Px, Py and Pz. D subshell has 5 orbitals and F subshell has 7 orbitals. Now you have studied in Pauli's exclusion rule that no orbital can accommodate more than 2 electrons. So here we can say that in P subshell it will be 6 electrons, so that each orbital will carry 2 electrons. Similarly, in S subshell it has 1 orbital, so it can accommodate only 2 electrons according to Pauli's exclusion rule. And similarly in D subshell it has 5 orbitals, so it can accommodate 10 electrons. So here we have a proof that why D subshell contain 10 electrons, because it has 5 orbitals and each orbital carries 2 electrons according to the Pauli's exclusion rule. So where F subshell has 7 orbitals and each orbital will accommodate 2 electrons, so it's gonna be 14 electrons. Now these are the shapes of s and p orbitals. S is spherical in shape and it can accommodate 2 electrons, where p is dumbbell shaped. It has 3 orbitals and each orbital carry 2 electrons with opposite spin. So 2px, 2py and 2pz, and they are dumbbell shaped orbitals. They both take part in bonding in hybridization to make new orbitals of same energy and shape. Now we will discuss that how hybridization takes place in these orbitals. Now we have to do the hybridization of carbon. So before starting hybridization, we should know about electronic configuration of carbon. Electronic configuration is done by atomic number. So here the atomic number of carbon is 6. Now if we put it into subshells, what will going to be happened? 1s contain 2 electrons and 1s is the subshell of K shell, while 2s and 2p are the subshells of L shell, and they both contain 2 electrons. As we know that S cannot accommodate more than 2 electrons. So here 1s has 2 electrons, 2s has 2 electrons and 2p has 2 electrons. Now p can accommodate 6 electrons, but we don't have the 6 electrons left behind. We have only 2 electrons which are left behind after filling 1s and 2s. So these 2 electrons will come in 2p. Now according to this electronic configuration, carbon should form 2 bonds. But carbon is able to form 4 bonds. So how it gonna be happened? Let's discuss. Students, basically this is the ground state of carbon, and carbon used to form bonds in its excited state. Now what is the excited state? It is the state in which one electron from 2s orbital will gonna jump to 2pz orbital, which is empty. As we know that p has 3 orbitals, px, py and pz, and if we have an empty or vacant orbital present, we can drop our electron to there. So here in 2s has 1 electron and 1 electron of 2s will gonna move to 2pz. So 2px has 1, 2py has 1 and 2pz has also 1 electron. Now it can form 4 bonds with 4 other electrons which come from another atom. So this is the excited state of carbon. Now don't you think that from where carbon gets energy to get excited? So guys, always remember, whenever bond formation takes place, whenever 2 atoms come together to form bond, energy releases. And this energy is utilized for the excitation of this electron to make it excited and move to another orbital. Now this is known as an excited state because here electron jumps to the more higher orbital of high energy, while in ground state they are present in lower energy orbitals. So that's why it is known as ground state. So now it's very easy to understand that carbon is able to form 4 bonds. So that's why carbon belongs to group number 14 and it has 4 electrons in its valence shell. So definitely the number of electrons in the valence shell represents that how many bonds an atom can form. Here we have to go with hybridization. What is the meaning of hybrid? Hybrid means to mix. And what we have to mix? We have to mix our orbitals. So the atomic orbitals mix together to give new hybrid atomic orbitals having same shape and energy. I've told you before that s orbital is spherical in shape. P orbital is dumbbell shaped. Now both of these orbitals will mix together to give a new shape. And that shape will be of same energy in all the newly formed orbitals. So now I will tell you that how it gonna be happened. Hybridization is very necessary. It tells us about the number of bonds present between atoms. Like here we are talking about carbon. So in carbon, single bond is present, double bond is present, or triple bond is present. It can easily be understood by studying hybridization. Then it also tells us about shapes of molecules, like it's triangular or it's tetrahedral or it's linear in shape. All can be easily understood by doing hybridization. It also tells us about the angle formed between the hybrid orbitals. Now we will do Sp3 hybridization, Sp2 hybridization and Sp hybridization. And at the end, I will tell you about some tricks by which you can easily understand hybridization in any compound. In carbon, Sp3 hybridization takes place. Like in methane, mixing of 4 atomic orbitals, 1s and 3p, with different shapes and energy, and when they mix together, they form 4 new hybrid orbitals having same shape and energy. Now we have studied that in excited state, carbon moves its electron to pz from 2s. So 1s and 3p orbitals are involving px, py and pz. All these 4 orbitals mix together to give 4 new hybrid orbitals. Like in Sp3 hybridization, we can discuss example of methane. Here is an example of CH4, which is also known as methane or marsh gas. Now what is happening here? We know that carbon belongs to group number 14 and it has 4 electrons in its outermost shell. 4 electrons are lying in 4 orbitals. And what are that orbitals? Can you please tell me? Yes, the 4 orbitals are 1s and 3p orbitals, px, py and pz. So 1s and 3p orbitals will combine together to give us 4 hybrid orbitals. And here you can easily understand that all these 4 orbitals have same shape, same energy. There is no one which is spherical or which is dumbbell. No, all of them are equal and all of them are same. No one is spherical and no one is dumbbell. It means now they mix together and form a hybrid orbitals. These hybrid orbitals of carbons have 1 electron in them. So in totality, they have 4 electrons, 1 in it, 1, 2, 3 and 4. So they will form bond with 4 other atoms. And in case of methane, that 4 other atoms are hydrogen atoms. So now 4 hydrogen atoms will come and form bond with 4 hybrid orbitals of carbon. So this is an example of Sp3 hybrid orbitals. The bond which is formed between carbon and hydrogen is a sigma bond. And in Sp3 hybridization, the angle is 109.5, while the geometry is tetrahedral. So here it's very easy to understand that carbon is acting as a central atom. and carbon belongs to group number 14. So all 4 electrons take part in bonding. So these 4 electrons will form hybrid orbitals, undergo hybridization and give us Sp3 hybridization. So in this way, methane will undergo Sp3 hybridization. Sp3 hybridization is carried out in saturated hydrocarbons. Single bond formation takes place. Now here, carbon can form bonds with other groups. Now group can be an atom or number of atoms. Like here, this carbon is joining with 3 hydrogens and 1 with CH3. So this CH3 is group of atoms. But this carbon is forming 4 bonds, 3 with hydrogens and 1 with this carbon. So this is an example of Sp3 hybridization. It's a formula of ethane. In case of ethane, carbon is forming Sp3 hybridization. 4 electrons of carbon are involving in bonding and they form sigma bond. So Sp3 hybridization is taking place. A single bond formation, which is a sigma bond between 2 carbon atoms, is taking place. So the bond formation between carbon and carbon is Sp3 hybridization, and the bond formation between carbon and hydrogen is sp3 hybridization. Now sp3 orbital is orbital of carbon, while s is a spherical orbital of hydrogen, from where it is donating its 1 electron to carbon. I hope you understand it. Now here this carbon is giving its 4 hybrid orbitals and each orbital is named as sp3 orbital. While the orbital of hydrogen which is involving in this bonding is s. So this will be sp3 hybridization. And in case of carbon and carbon bond, this carbon has 4 sp3 hybrid orbitals and carbon number 2 also has 4 sp3 hybrid orbitals. So the bond formed between carbon and carbon is sp3 hybrid orbitals. Now here is sp2 hybridization. The name indicates 1s and 2p. Now 1s and 2p orbitals of different energies and shapes are mixed together to give 3 orbitals of same energy and shape. 1s and 2p joins together to give 3 orbitals. So this type of bonding will gonna occur in unsaturated hydrocarbons. And this unsaturation comes because of 1 orbital which left behind, and that is pz. We can say it that 1x, 1s and px and py take part in hybridization, while pz will left behind, and that pz will join together to give unsaturation. Now let's discuss how. This is an example of sp2 hybridization. Ethene. Ethene belongs to alkenes, so unsaturation will occur. Double bond formation will take place. Now in this double bond, this carbon is forming sp2 hybridization. It formed 3 bonds, sp2 hybridization, and 1 bond of carbon is formed by pz orbitals. So it will form 3 sigma bonds and 1 pi bond. Here this carbon, carbon number 1, is attached with 2 hydrogens and 1 carbon. So there are 3 orbitals. With 2 hydrogens and 1 carbon, it will gonna be 3 orbitals. And this upper bond is formed by pz orbitals and it will be a pi bond. So this is not taking part in hybridization. As I have told you before that pz orbital is not taking part in sp2 hybridization. sp2 hybridization is done only by px, py and s orbitals. So these three are hybrid orbitals and this unsaturated bond is formed by pz orbitals and it will be a pi bond. Now the angle between the hybridized orbitals is 120 degree and the shape is triangular. Now sp hybridization. In sp hybridization, 1s and 1p will gonna involve. As the name indicates, 1s and 1p orbitals of different energy and shapes. Definitely S is spherical and p is dumbbell shaped. But when they both mix together, they will give two new orbitals of same energy and same shapes. So this will also be an unsaturated bonding. Unsaturation will take place in it. Now this is sp hybridization. In sp hybridization, 1s and 1p will gonna involve. Here, if I talk about carbon number 1, this is ethyne, belongs to alkynes and it forms triple bond. So it is an unsaturated compound. Now if I talk about carbon number 1, with how many atoms carbon number 1 is attached? Carbon number 1 is attached with 2 atoms. So it is involving its 2 hybrid orbitals. One atom is hydrogen and the second atom is this carbon. Now it's not matter to us that with how many atoms this carbon has been attached. At this time I am discussing about carbon number 1. So in carbon number 1 is attached with hydrogen and with this carbon. It is forming 2 bonds, so it is sp hybridization. 2 hybrid orbitals of carbon is involving. So from where these 2 bonds will come? The rest of the 2 bonds, as this carbon is forming 3 bonds with another carbon. These 2 bonds will come from py and pz orbitals. Here is an example, like this is our central atom, carbon. And carbon is forming 1 bond with hydrogen atom, 1 with another carbon. This is sp hybridization. The remaining 2 orbitals py and pz will overlap with each other. Py of first carbon will overlap with py of second carbon to form pi bond. Pi bond is weaker than as compared to sigma bond. Why? Because sigma bond is a bond formed by head-on-head overlap, while pi bond is formed by tail overlap. So it will be weaker than as compared to sigma bond. Here 2 bonds of carbon and carbon are formed by py and pz orbitals, which will be pi bonds and weaker bonds, while the 2 bonds, one with hydrogen and one with another carbon, is formed by sigma bonds. The angle between the hybridized orbitals will be 180 degree in sp hybridization and the shape will gonna be linear. So now there is an hybridization trick for you and it will gonna make much easy for you to find out hybridization in any compound. But for this, first of all, what you have to do, you have to find out central atom in a compound. Like if I talk about methane, so the central atom is carbon. Central atom is an atom which is occupied by all other atoms, or it is occupied by atoms which are multiple in number. Like carbon is single, but hydrogen is multiple in number. So here carbon is the central atom. Now we have to go with carbon. Carbon belongs to which group? Group number 14. So how many electrons are present in the valence shell of carbon? Yes, 4 electrons. These 4 electrons are forming, we have to consider these 4 electrons to understand the hybridization trick. Now how many sigma bonds are forming in methane? We can find out sigma bonds by noting that how many number of atoms are attached with the central atom. Now here, how many number of atoms of hydrogen are attached with carbon? 4. So definitely carbon is forming 4 sigma bonds. And if it is forming 4 sigma bonds, then it will be 4 hybrid orbitals. And if we have 4 hybrid orbitals, it will be Sp3 hybridization. So by knowing the chemical formula, you will be able to understand that which type of hybridization is taking place. As it is combining with 4 hydrogens and it has 4 electrons in its valence shell, so they are forming 4 sigma bonds, and these 4 sigma bonds are 4 hybrid orbitals, 1s and 3p. So it's Sp3 hybridization. Let's move towards second example. Aluminium chloride. So now, aluminium belongs to which group? Aluminium belongs to group number 13. So how many electrons present in the valence shell? It has 3 electrons in its valence shell. So here aluminium is the central atom and we have to consider aluminium for hybridization. So 3 electrons are present in the valence shell. Here these 3 electrons are forming bond with 3 chlorines. So how many sigma bonds are forming? 3 sigma bonds. If 3 sigma bonds are forming, it will be 1s and 2p. So it will gonna be Sp2 hybridization. Quite easy now. Now magnesium chloride. In magnesium chloride, magnesium belongs to group number 2. So how many electrons in its valence shell? It has 2 electrons. Here magnesium is the central atom. So we have to consider magnesium for hybridization. It has 2 electrons in its valence shell and these 2 electrons will form bond with 2 atoms of chlorine. Chlorine has 1 electron in its outermost shell as it belongs to group number, it has 7 electrons in its outermost shell as it belongs to group number 17. So here chlorine will take 1 electron from magnesium and it will gonna form 2 sigma bonds. So now magnesium belongs to group number 2. It has 2 electrons in its valence shell and it will form 2 bonds with chlorine. These 2 bonds will be sigma bonds and it will undergo sp hybridization. 1s and 1p will give 2 sigma bonds. So now here is an example of ammonia. Nitrogen is the central atom because it is attached with multiple hydrogen atoms. Now nitrogen belongs to group number 15. So how many electrons present in the valence shell? 5 electrons. And how many electrons are taking part in bonding? Only 3, because it is joining with 3 hydrogen atoms. So out of 5, 3 are forming sigma bonds. And how much left behind? Total were 5, 3 form sigma bond and the 2 will be left behind. When we have 2 electrons, we used to say it 1 lone pair. So the 2 electrons will represent 1 lone pair. So here can I say 3 sigma bonds with hydrogen and 1 lone pair. As it belongs to group number 15, I have 5 electrons. So these 5 electrons, 3 will form sigma bond and the remaining 2 will act as a lone pair. and considered as one lone pair. So in totality, I have 3 sigma bonds and 1 lone pair, it will be 4. And 4 hybrid orbitals will undergo Sp3 hybridization. So I hope it's gonna be quite easy for you now. In the next example, I am taking water. Now can you please tell me what is the central atom? Exactly, you are quite intelligent. Oxygen is the central atom. And oxygen belongs to group number 16. It has 6 electrons in its outermost shell. From 6 electrons, 2 are making bond with hydrogen. So the left behind will be 4 electrons. 2 sigma bonds are formed with 2 hydrogen atoms. And the remaining 4 electrons of oxygen will form 2 lone pairs. A pair of electron represents one lone pair. Here we have two pair of electrons, means 4 electrons, so we have 2 lone pairs. Now 2 sigma bonds and 2 lone pairs. In totality, we have 4 bonds. And 4 bonds undergoes Sp3 hybridization. 1s and 3p accommodates or can turn into 4. So it will be Sp3 hybridization. So now let's discuss about SCl4. Here S is the sulfur. It is the central atom. It belongs to group number 16. It has 6 electrons in its outermost shell. Now what's going to be happened? These 6 electrons, 4 will form bond with chlorine. So it will form 4 sigma bonds. And how much left behind? 2 electrons will left behind. Out of 6, 4 are forming bond with chlorine and 2 will left behind. These 2 electrons will form a pair of electron and undergoes or can be said as one lone pair. So 4 sigma bonds and 1 lone pair. How many total? It will be 5. 4 plus 1, 5. So 5 will undergo Sp3 dehybridization. 1s, 3p forms 4 and 1d will form 5. So here our 5 bonds will complete and it will undergo Sp3 dehybridization. Now here is the ion. This trick can also be applied on ions, but you should know that if I have a positive sign on my ion, I have to cut the electrons. And if I have negative sign on my ion, I have to add the electrons to the central atom. So I will move this charge to my central atom. And what is the central atom? Central atom is nitrogen. So here nitrogen belongs to group number 15. So it has 5 electrons in its outermost shell. And the positive one indicates that I have to remove 1 electron. So out of 5, if I remove 1 electron, it will gonna be 4. So now my central atom nitrogen has 4 electrons. These 4 electrons are forming 4 bonds with hydrogen, as there are 4 hydrogen atoms present in NH4 positive. So now 4 sigma bonds are forming with 4 hydrogen atoms. So 4 sigma bonds means 4 hybrid orbitals, and 4 hybrid orbitals means Sp3 hybridization. 1s and 3p joins together to give 4 hybrid orbitals. So it will undergo Sp3 hybridization. So only by noting a formula and by finding central atom, you just have to find out that from which group your central atom belongs. And this will going to tell you that how many number of electrons will present in the valence shell. And we all know it that the number of atoms present in the valence shell represents bonding. only the valence shell electrons are taking part in bonding. So the number of electrons present in the valence shell will tell you about bonding. And the multiple atoms which are joining with the central atom, it will tell us about how many sigma bonds are forming in an atom. While the remaining electrons will tell us about the lone pairs. So in this way, by knowing the chemical formula, we can easily understand about hybridization. I hope this topic is pretty clear to you now. Thank you so much.